Hi, this is Miss Wise, and I am going to tape a video today talking about dilations, what we first started talking about at the beginning of the year. So, dilations is a form of transformation, and this particular transformation either enlarges or reduces an image. And there's one word that I forgot, proportionally. Okay, so we're talking about, like, if you're going to a copy machine and you are enlarging something, you're going to take 120%. Well, it's going to dilate proportionally to the original. So dilations are non-rigid transformations. That's a word that I want you to remember, meaning that they are similar, but they are not congruent. So non-rigid means similar, but not congruent. And the reason rigid figures don't change, but similar, and those are, rigid figures would be congruent. Similar figures change. They're not exactly the same or congruent to the original, so they are considered non-rigid. When we are doing dilations, there's a scale factor, and so we went over this in class. But the scale factor is, if the scale factor is greater than 1, then it's an enlargement. Oop, I can't spell enlargement. Enlargement. If the scale factor is between 0 and 1, so this would be the scale factor in between. So we'll just say SF for scale factor and SF for scale factor. Then this means that it is reduced from the original. So another part of this is when we have coordinates. And let's say we have a triangle, and the coordinates are 1, 1, 3, 3, and then 1, 4. And I say I'm going to enlarge the figure by a scale factor of 2. This would mean that I'm going to, this is my scale factor, so I'm going to multiply each of the two coordinates by 2. And so to find my image, because this would be my pre-image, and we went over that in class, my image, this point A and this point A prime is now going to be 2, 2. And then B prime, because this is my original B, is going to be 6, 6. And my C is originally 1, 4, so my C prime is 2, 8. So that gives you an idea of what I'm talking about when I'm talking about a scale factor and enlarging or reducing a figure. Like, we could have had a scale factor of 1/2 here, and so I would have multiplied each of them by 1/2, each coordinate by 1/2. So moving on along, we did some examples, and I'm going to look at example number 8. And the reason I'm going to look at example number 8, and this is actually on page, let me get the right page for you guys. Number 8 is on page 5 of your packet. I'm going to go through and I'm going to do this one with you. So I have the quadrilateral, it looks like maybe U, J, E, G. Or let's do U, and so that coordinate is 1, 2, 3, 4, 5, negative 5, 0. And it looks like J is going to be at 0, 0. And then E, oh, let's not do that. Let's do G next, because I want to go in order, is going to be 1, negative 1, 2, 3, 4, negative 4. And then E is going to be 1, 2, 3, 4, negative 4. and then I believe that's -5. We'll count 1, 2, 3, 4, 5. Yes. So these are this is my pre-image. Now in the problem number 8 on page 5, it says for dilation of 0.25, so but it's about -1, 0. So this is my center of dilation. So center of dilation. Whereas a lot of times the center of dilation is 0, 0. But in this case, it's not. So let's see if we can see better if I turn off the lamp. There we go. So I'm going to, my scale factor is 0.25. So each one of these I'm going to multiply by 1/4. So I'm going to multiply -5 times 1/4, so that's -5/4, and 0. And when I multiply 0 times 1/4, it's 0, and then 0 times 1/4 is 0. I'm going to 1 times 1/4 is 1/4, and then -4 times 1/4 is -1. And then again, -4 times 1/4 is -1, and then -5/4. So that gives us an idea of what it would be if the center of dilation is at 0, 0. So, but it's not at 0, 0. So we're going to have to translate it over to the left, -1, but I'm not going up or down any because that's 0. So for instance, instead of having -5/4, I'm going to have -9/4 because I'm going to add 1 to it. Then instead of having 0 for my x value, I'm going to have 0 plus -1, which will be -1, and 0 because my y value is translated by 0. My next one is 1/4, and I'm going to subtract 1 from that, so that's going to be -3/4. And then I have -1, and I'm going to stay at -1. Then I have -1, and I'm going to go over another -1, so that's -2, and then my y value is going to stay the same. So these would be my new points of my image. So this is going to be u prime, j prime, g prime, and e prime. So that's how you work with that. Now the last thing that I wanted to cover was the center of dilation, and how do we determine the center of dilation. So I am going to probably have to do a problem that I have already done, but so looking here at this problem right here, I am going to take a ruler, and to find the center of dilation I'm going to draw a line and extend it through C and D prime. So I'm just going to use my phone as a straight edge. D and D prime. And what you're going to find out, that's not D prime, so D and D prime, and what you're going to find out is they're all going to converge or come together at a point that is actually A prime, which is going to be -4 and -4 and -1. So my center of dilation for this case would be -4, -1. So that covers that a little bit. If you will flip the page, so that was on page 6. If you will flip the page to page 7, and we can go over some of the problems that we did in relation to identifying the scale factor. So here, if you look down here at the bottom of the page, or let's just do one of these that we can actually see pretty well. Here I have this square right here that's dilated to, actually this square right here is dilated to the image Q prime, P prime, and the rest of it. So I have my new over old. So my new corresponding side is 4, and my old corresponding side is 10. So my dilation scale factor is 2/5. So that kind of gives you an idea of the fact that it's a reduction and it's being reduced by 2/5. So that kind of goes through that, and then I will tape another video starting to talk about polygons.